Gerald McKeegan at the Chabot Space and Science Center in Oakland, California. He'll start with some historical observations about the equipment, and he'll move on to some of his research.
Hi, I'm Gerald McKeegan. This is our oldest telescope. This is the original Oakland Observatory telescope. It was built in 1883 by Alvin Clark and Sons. The telescope was donated to the Oakland Observatory by Anthony Chabot, who was an engineer and hydrologist in the Bay Area at that time. He was the head of the Contra Costa Water District, and he donated $3,000 to build this telescope and the observatory. The original location of the observatory was in downtown Oakland in Lafayette Park. And it was opened in 1883 right across the street from the high school. The telescope originally belonged to the Oakland Board of Education, and they operated the telescope for students at the high school. But one of the stipulations that Anthony Chabot made was that the telescope would always be available for public viewing for free. So from 1883 until today, we still operate this telescope for free public viewing. Now, at the time he made the donation, he stipulated that the telescope and the observatory would not be named after him. But when Anthony Chabot died, they changed the name to the Chabot Observatory, and eventually it evolved to become now the Chabot Space and Science Center. So just tell you a little bit about this telescope. This is an 8-inch refracting telescope. That means it's a long tube with a lens at one end and an eyepiece at the other end. That lens is 8 inches in diameter. It's on an equatorial mount, which means that the telescope can track, as we're observing, it can track the motion of the stars caused by the rotation of the Earth. It has a drive system here that today it's an electrical drive system. In the original telescope, it was a mechanical drive, like on a grandfather clock, with a weight and a chain, and you pull the chain and the weight, as it slowly descends, it would drive the system. Today we have an electric motor on here, and what that does is turn the telescope in the opposite direction that the Earth rotates, but at the same rate of speed as the Earth rotates. And by doing that, you keep the object you're looking at centered, and you're compensating for the rotation of the Earth. You'll notice on the top of the telescope there's a short tube up there. That's actually a camera. That camera was installed several years after the original telescope was built. It uses glass plates. You'll look on the back end, you can see that there's a frame for the glass plates to be mounted. You'd point the telescope at an object that you wanted to photograph, and then if you look carefully up there, you'll see that the front end of the camera opens up, so it's like a shutter, and that opens, and then you take a long exposure and then close it, and then go develop the glass plate. And that was used back in the 1920s, 1930s for astrophotography with this telescope. Telescope can be moved and pointed in any direction. We can move it like this, and we can also move like this. So we call this motion declination, and we call this motion right ascension. And by moving in combinations of those two, we can point the telescope at any object we want to look at in the sky. The dome rotates, so we just turn the dome and point it in the direction that we want to look, and open the shutters and start observing. So you'll see some numbered dials on here. This is the declination dial that shows the angle that we're looking at in declination. Declination is measured north or south of the equator. For example, we might look at an object that's 20 degrees north of the equator, so we would dial that in there. Right ascension is a little more complicated with this telescope. We use what's called an hour angle. An hour angle is the angle between the object we want to look at and the meridian. The meridian is a line between that goes from the South Pole through the zenith to the North Pole. And the object that we want to look at is some angle from that line. And so that's what we measure here with this scale. The tracking system can only run for about 2 hours. So after about 2 hours, we have to stop the telescope, reset the tracking system, and then reacquire the object and then start tracking again. So this is again our oldest telescope. It was built in 1883. We give all of our telescopes names. This one we call Leia. So what we're going to do now is transition, and we're going to go over and look at our second oldest telescope, and that's our 20-inch telescope. So these are just photographs showing the second Chabot Observatory site. This was in the Leona Heights part of the city of Oakland. In fact, it was located right at the end of what was in the streetcar trolley system. And you see the building here. You'll notice that the building has 2 domes. The smaller dome housed the original 8-inch telescope, Leia, and then the bigger dome was for the new telescope, Rachel. So this is the 8-inch dome, this is the 20-inch dome. At that time, it was a very nice location. Like I say, it was right at the end of the trolley line, so it was easy for people to get to. And there was not a lot of lights or anything around it, so it was a really nice dark location. That location, however, over time had more and more light pollution. A lot of trees started growing up, and it turned out it was also located on the Hayward Fault. So that became a problem. Once they realized it was on the Hayward Fault, there were concerns about it not being earthquake safe. And so the school district actually closed it for a while. Then they reopened it for only public viewing and no longer brought school groups here. And they started looking for a new site, and they moved to the new site in the year 2000. The original Chabot Observatory was built in 1883 in what is now downtown Oakland. As the city grew, they started installing electric street lights and house lights and so forth, and pretty soon light pollution became a problem for the observatory. So in the early 1900s, they began looking for a new site. At that time, the director was Charles Burkhalter, and he led the effort to try to find a new site. Eventually, they found one in the lower part of the Oakland Hills near what is now the intersection of Interstate 580 and Highway 13. So in the early 1900s, they actually, I think it was around 1915, they moved into that site. And at that time, they also acquired a new telescope. So they contracted with Warner and Swasey and Company to build the telescope tube and the mount, and with John Brashear to build to make the optics for the telescope. So together they worked on the telescope and eventually built what is now our 20-inch refracting telescope. This is a refractor telescope, so it's a long tube. It's 31 feet long. At the front end of the tube up here, you see where the 20-inch lens is, and then it's just a long hollow tube to the back end of the telescope where the eyepiece is. You can see that the mount is much larger than the mount for the 8-inch telescope, and that's because the longer the telescope is, the bigger the mount has to be. This is also an equatorial mount, so I'm going to show you here in a second how the drive system worked. This is also an equatorial mount, so it tracks the object we are viewing, compensating for the Earth's rotation. Now today, we have an electric drive on the telescope that does that. But in the early days, it had a mechanical drive. So there was a weight on a chain, you pull the chain, raise the weight. As the weight descended, it turned the drive system. So in here you see what was then the speed governor for the mechanical drive system. The drive system had to turn the telescope at the same rate as the Earth's rotation, the same angular rate as the Earth's rotation. So this speed governor assured that that would happen with the mechanical drive system. This telescope has been in use for public observing since the year 1916. Although it was built in 1915, it did not immediately go to the Chabot Observatory. In 1915, there was the Panama Pacific exhibition in San Francisco, and Warner and Swayze Company wanted to display the telescope at the exhibition. So for the majority of the year 1915, the telescope was in San Francisco at the Panama Pacific exhibition. At the end of 1915, they brought it across the bay to the new Chabot Observatory site and installed it, calibrated it, and then they started public viewing through the telescope in March of 1916. Again, this is a 20-inch refractor. It's very similar in design to the 8-inch refractor, Leia. This one is called Rachel. And if you look up here, you can see the declination axis, that numbered axis right there, and then the right ascension axis is over here. Like Leia, you move the telescope around those two axes to point the telescope at the object you want to view. Once we're on the object, we rotate the dome to align the opening of the dome with the telescope and the direction that we're trying to view. Okay, I think now what we'll do is head on over to look at our newest telescope, the 36-inch reflecting telescope.